In this lecture, we are going to discuss about the mutual information. Like what is uh, information? First, we will try to discuss the definition of the information. So, the reception of a message about a certain event, for example, experiments results, brings up is information. Of course, the information is received only if we do not know the content of the message in advance. This suggests that the concept of information is related to the ignorance about the result of the event. Second point is that we gain information only because of our prior uncertainty about the event. Like we do not have any knowledge about the event, so that is why we are getting some information. We can say that the amount of a priori uncertainty equals the amount of information delivered by the subsequent knowledge of the result of the experiment. Information resources can be modeled by random processes whose statistical properties depend on the nature of the information sources themselves. A discrete time information source X can then be mathematically modeled by a discrete time random process. Mathematically, we can define the information contents uh, like ij. So j is basically this index of the symbol is equals to log of 2 1 over probability of that symbol. So if you take that probability upstairs, the power is minus 1, and you know in logarithm the power is always come in front of log. So that is why it is I is equals to minus log 2 probability of pj. So log 2, so that is why its unit will be bits per second. The information will be represented in bits. So this is the technical definition. The information content does not depend on the possible interpretation. It only depends on its probability. Like if a message has a low probability, then it contains more information or it gives more information. For example, if we want to calculate the amount of information whose probability pk is equals to 1 by 4, so what will be its information? So like if you take the log of 2 1 by 4, the answer will be equals to 2 bit. Second example, in a binary PCM, if a bit 0 occurs with the probability of 1 by 4 and a bit 1 occurs with the probability of 3 by 4, then calculate the amount of information conveyed by each bit and give comments. Like I want to have this example for you to solve and give me the answer in the comment box. But before that, I will try to give you more example about the information. Like I will explain a bit more about the information so that you can better understand what is the mutual information. Again, I want to discuss its definition of the information. The reception of a message about a certain event brings us information, or the concept of information is related to the ignorance about the result, that you don't have any knowledge about the results. That is why you are getting information. Or we gain information only because of our prior uncertainty about the event. And mathematically, we can define the information is equals to log to 1 over probability of g, which is equals to minus log 2 pj. So, like if this type of transmitter and receiver you have, and you are transmitting the information from the transmitter, and then your message is being being processed by different electronic circuits. We don't care about those circuits. We just say it is a transmitter, and then it passes over through the channel, and then the receiver will receive that message and it reprocess again what has been done on the transmitter. On the receiving side, it will undo all the information, and then at the end you will get the estimated information. So basically we are talking about the uncertainty. So uncertainty means that if you have a message like x, which is have a values a realization x0 x1 comma xn, and the probability of all the realization is p0, p1, and up to pn, and we know that the total probability p is equal to the sum of all the probabilities. For example, a symbol x0, and we say that we send x0 with the probability p0 is equals to 0. So it means that we have a full confidence that the symbol 0 has a probability p0, and we know that it doesn't happen. But if we say that the symbol x0 has a probability 1, so it means that it is 100% that this will happen. So there is a no uncertainty in this case. So it means that the probability of event is 0, not happen. But if we say that the probability of the event is equals to 1, so it means that the 100% it will happen. So there is a no uncertainty. But if we say that the symbol x0 has a probability which is equals to zero point 0.5 or equals to zero point 0.1, or you may say equals to zero point 0.2, so it means that you are asking about the uncertainty because you don't know how many symbols are there and what is the probability of all others, and so how much the probability of this one is. So that is why there is uncertainty. So this is a general term, like if the probability is decreasing, so like here it is zero point 0.5, so more uncertainty, so its probability is zero point 0.1, it's less probability, so it means that the probability is decreasing, so but the uncertainty will increases. So we will prove this property in our next few slides, for example. So the information also has some measure. It has some properties. A measure of the information. What is measure of the information? It is an information content of a message. That is basically the measure of information. The first property is that consider an information source emitting an independent message. So the message is equals to can be the combination of m1, m2, comma up to mn with the occurrence of probability, like the probability of m1 is p1, probability of m2 is p2, probability of mn is pn, and the total probability will be equals to the summation of all the probability, that is equals to 1. And we can measure the amount of the information with this formula, like ik is equals to log 2 1 by pk, and you will represent this information in term of bits because the base is 2. So there are few properties of the information, like more uncertainty about the message, you will get more information, because if the probability is less, the uncertainty will be more, and then you will get more information. For example, we have two messages, p1 whose probability is 1 by 4 and whose uncertainty is u1, and p2 whose probability is 1 by 2 and whose uncertainty is u2, and we say that the p1 has less probability, so its uncertainty is bigger, and p2 has a bigger probability, so its the uncertainty of u1 is greater than the uncertainty of u2, because the probability of p1 is less than the probability of p2. And we will prove it, like for example, so if the information of I1 is equals to log 2 1 by P1, and we know what 1 by P1 is equals to 1 by 4. So 1 by 4 is the third denominator, you can take it out. So the log 2 to the 4, so you know it is 2, 2 raised to the power 2 is equals to 4. So log 2 2 will be equals to 1, 2 multiplied by 1, answer is 2 bit. And about second message, I2, again using the same formula, inserting the probability here, and you will end up with 1 bit. So it means that the information I1 is bigger than the information I2. So this shows that the if the uncertainty is bigger, the probability is less and the information is more. Second property is that receiver knows message being transmitted, then information is zero. Like if the receiver already know what is the message that has been transmitted, then in that case it is not adding any extra information. So that is why the information will be zero. So in that case, if the receiver already know the message that has been transmitted, then the probability, we say that the probability will be equal to 1, that is 100%. The receiver knows everything. So in that case, we can calculate the information is equals to log 2 1 by p. So if p is equals to 1, so 1 by 1 log 2 of 1 is equal to 0. So this shows that the information is a 0 because the receiver already know what has been transmitted. So that is why it is not adding any extra information. The third property is that I1 is the information of message M1 and I2 of M2. Then combined information of M1 and M2 will be equal to I1 plus I2 in case the M1 and M2 are independent. For example, I1 is the information of message M1 whose probability is P1. I2 is the information of message M2 whose probability is P2, and M1 and M2 are independent, so the combined probability will be equal to 1 P1 multiplied by P2. So the total overall information is equal to log 2 1 by P, which is equal to 1 by P1 multiplied by P2. So this is a product and we know logarithmic formula. So log of the product is equal to log of x plus log of y. So you are opening that product with the summation sign. So log of 2 1 by P1 plus log of 2 1 by P2, and we know this is equals to I1 and this term is equals to I2. So the total information is equals to the sum of the individual information of the messages only if the messages are independent. Another property is if there are m is equals to 2 raised to power n equi-likely messages, then amount of information contained by each message will be equals to n bit. For example, the probability of each message is equals to 1 by m because they are equi-likely. So the information is equals to log to 1 by p, or 1 by p means we can write the probability is equals to 1 by m. So that is equals to log 2 m. So m is equals to, we know m is equals to raised to power n. So if we insert m here, 2 raised to power n, so n is the power, so that is power will be here. Then log 2 of 2 will be equals to 1. So the information will be equals to n bit. So that is the property. So let's do some example in the next session. So thank you for watching this session. So keep subscribing the channel so that you will see few more example, and then you might understand a bit more about the mutual information. So if you have any questions, so you can write the answer in the comment box and we will try our best to answer the question. Thank you for watching.